You've probably seen the videos claiming you can ditch Claude or Claude Code for a local model. And for a lot of jobs, that's genuinely true. Smaller local models handle code, file search, document summaries, and repetitive work just fine, without sending anything off your machine. But then someone on X asked a much bigger question. What would it actually take to run Kimi K3, the model people are now comparing to Anthropic's Opus class models, on your own hardware? How many NVIDIA GPUs? How many Mac Studios? I also dug up a Reddit thread asking what it would take to serve an Opus class model locally to 100 people. The guesses were everywhere: 4 H100s, 8 B200s, just get a rack. Nobody agreed. So that's what this video is about. Kimi K3 is a mixture of experts model with 2.8 trillion total parameters. Only 16 of its 896 experts activate per token, which cuts down the compute needed per response, but it doesn't shrink the model. Every expert still has to sit in memory somewhere, because the router can pick a different set for the next token. Moonshot ships the weights in MXFP4, a 4-bit format. Half a byte per parameter times 2.8 trillion parameters lands you at roughly 1.5 terabytes just for the raw weights. That's before quantization overhead, inference software, active conversations, or any safety margin. So the laptop question. The biggest Mac Studio configuration tops out at 512 gigabytes of unified memory. Not close, even a hypothetical 2-bit version would still need around 700 gigabytes. A Mac Studio is a great machine for plenty of local models, just not this one. 4 H100s. That's 320 gigabytes of GPU memory total, less than a single maxed out Mac Studio. Also not enough. 1 DGX B200, 8 B200 GPUs, 1.44 terabytes of GPU memory combined. On paper, that's close to the 1.5 terabyte estimate. In practice, it leaves you maybe 40 gigabytes of headroom once you account for runtime overhead. Context and serving software. Technically at the floor, not a setup I'd call practical. A DGX B300 is more realistic, 8 B300s, about 2.3 terabytes of GPU memory. That leaves roughly 900 gigabytes above the raw weight estimate, which is enough breathing room to actually load the model. We still need real benchmarks to know how fast it runs, but it's at least plausible on paper. Here's the catch, though. Moonshot's own launch materials recommend a supernode of 64 or more accelerators for efficient inference. That's not the minimum to load the model, it's what they recommend to serve it well. 64 accelerators means 8 of those 8 GPU servers minimum. That's not a box under your desk, that's a data center footprint. What changes at 100 users? The Reddit thread's framing was off in a useful way. 100 users isn't the same as 100 simultaneous requests. If 100 people each send one request every 10 minutes, and each response takes 30 seconds to generate, you're looking at roughly 5 concurrent requests on average, not 100. But that number moves fast. Agentic workflows change everything. One developer running several coding agents in parallel can look like several users' worth of load on their own. And Kimi K3 supports up to 1 million tokens of context. That's a ceiling. Not a typical request size. But longer prompts eat more runtime memory and processing headroom. The part people underestimate. Physical reality. 1 DGX B300 takes up 10 rack units and draws about 14.5 kilowatts, per NVIDIA's own numbers. 8 of those servers, the efficient inference setup, adds up to roughly 116 kilowatts before you even count cooling. Someone on Reddit who runs several dozen B200s described flipping them on as sounding like sitting behind an Airbus A380. You also need networking, storage, power delivery, cooling, monitoring, and people to run all of it. On the cost side, multiplying today's public 8 by B200 node pricing by 8 nodes puts you around $313. $0 to $577, $0 a month for compute alone. That's rough scale math, not a quote, but it tells you the order of magnitude. So what's the actual answer? The best comment I found in that Reddit thread wasn't about GPUs at all. Someone who'd actually run an LLM service for thousands of users said it plainly. Models that are good enough in that scale beat super models that only serve a couple. The pattern wasn't fully local. It was local models for private or repetitive work, and cloud models like Claude or GPT for the genuinely hard tasks. One commenter had the simplest advice of all. Rent the hardware for a couple of weeks, put it in front of real users, and see if it actually holds up. That tells you more than any benchmark chart will. The bottom lines. A single Mac Studio can't hold full Kimi K3, for H100s can't either. An 8x B200 server just barely reaches the raw weight requirement, with almost nothing left over. Moonshot's recommendation is 64 plus accelerators, a data center deployment. If this cleared up what actually running K3 costs, subscribe, that's the only pitch in this video. See you in the next one.